Now we're going to record it. And now we're good? All right. And you know what? We're exactly on time. You know what it was? I was trying to start early, and you didn't want to let me do that. All right. So this afternoon, I am the last session, the only thing standing between you and getting to watch the Avengers. So bear with me. Unfortunately, I won't start any earlier if I end sooner. I want to talk to you today about common design patterns. And these are design patterns mostly, pretty much all of them, I think, from the Gang of Four design patterns book that's been around for probably like 20 years now. This is me. My name is Steve Smith, one of the organizers of the conference. And like I said, I work at Falafel Software. I'm a little bit sleep deprived tonight, although last night was great because I didn't get woken up at all by the twin babies that I have, which are adorable and look like that. So this is my obligatory kids on the giant screen picture. Recently, I've been working with some clients, and in a conversation we had, I was able to show them this slide, which I really like, and some of you maybe haven't seen, where it kind of drives home the point that, you know, if you don't have time to improve your processes and to improve how you're doing things, it's not necessarily going to work out for you in the long run. It may not even work out for you in the short run. You know, I love Legos, and I love, you know, this guy's just kind of standing there like, hey, guys, and, you know, they're like, sorry, too busy. And that's what I feel like a lot of the time when I'm working with clients and I'm trying to share, like, there might be a better way. Have you thought about this? You know, you don't want to overkill things with patterns or architecture, and we'll talk about that as well. But it is something to keep in mind is, can you do something a little better? And I don't have my handy slide advancer, so I'm cheating with a mouse, and I have to get it in just the right spot. This is a Pluralsight that I mentioned, so those of you that got cards, congratulations. These are a bunch of courses that I have. There's a design patterns library out there that talks about all of these patterns. So you can check out more there, and that's really hard to see. And then design patterns in general. How many of you already use design patterns and know what they are? You know, show of hands, at least one, right? You expect most of the hands to go up. Great. What design patterns are is basically a repeatable pattern that you can apply to a problem. And they're not like a cookie cutter solution where you can just copy paste the block of code and throw it in and it just does the thing. It's just an approach to a problem. And it also provides us with a higher level of talking about the problem so that we can have a conversation with our team and use a term that has much more meaning to it than the lower level terms that make up that pattern, like the individual constructs or objects or loops or what have you. So let me talk to you for a moment about the stages of learning, and not just for design patterns, but in general, whether you're a musician or a martial artist or an artist or whatever. When you start to learn a new concept, like, say, design patterns, you may find yourself going through these stages that probably if I were an education major, I would know better names for these things. These are names I made up. So the zero stage is where you have no idea what this thing is. And so if somebody says, hey, do you know about the strategy pattern? You're like, what's that? Never heard of it. And that's where you start out on everything. And then you hear about this thing. And it might be that you hear about it on a blog or at a conference or whatever. But that's where you start to reach this what I call awakening stage, where you're curious about it or you've just heard about it. And maybe it's piqued your interest, maybe it hasn't. Maybe you have to hear about it a few times before you realize, you know, I keep hearing everybody talk about this JavaScript thing. Maybe I should learn some of that. And then maybe you start to get bit by the bug that, you know, you really want to try this thing out. So you spend a few nights and you learn about it, or you go to some training, you come to one of these talks, and you go into this overzealous mode where you start thinking, wow, I'm going to use this thing everywhere. This is the best thing ever. I think I could probably use XML everywhere, Microsoft, most of after the 90s. You know, so you try and get this overzealous part out of your system to where you actually know when it is appropriate to use this thing. And so you get to this mastery level where you don't have to try to apply this pattern or this skill. It's just sort of muscle memory at that point. You know, you see this problem, you know the solution, you just apply it, and you drive on, and it doesn't really slow you down any. I'm hoping at the end of this talk that for about half a dozen design patterns, you'll at least be at the awakening level, and maybe you'll move on to the extra levels after that based on your own research. And I'm sure a lot of you already know some of the patterns I'm going to talk about, so you might learn a trick or two on how to use them. In terms of design patterns for the purpose of language, Each design pattern has a name. And a corollary to the design patterns that I don't have time to talk about today is anti-patterns. And anti-patterns each have names as well. In both cases, they serve a great purpose, which is that when you're communicating with your team, instead of saying to them when you see a code smell or something in the design, it's making it overly coupled or something, instead of saying, well, we could extract an interface and then create a new class that implements that interface, and in that class, we could go talk to the database, return back the results using an abstraction that this thing could then use. You know, that takes a lot to say and explain when, if both of you are familiar with a pattern, you could just say, well, why don't we use the repository pattern here? And boom, both people are like, okay, I know what that means. I'm going to do all those steps I just said, but I'm going to sum it up in one word. And that's what each of these design patterns is designed to achieve, is to let us have that higher level conversation with our team members as we're talking about design in our software applications. For this talk, before I first gave it, was a couple years ago, like I guess it's been like 4 years ago, I did a poll on Twitter and then asked, like, what are the most common design patterns you use? Basically, I just asked 300 some people, which design patterns do you use? And you can kind of see the spread here of which ones are the most commonly used at that time. I'm sure it's changed a little bit. I should probably do another survey. Maybe I'll like ping all of you after the show or something if I can get the rest of the board to agree to something like that, which is unlikely. But you can see like factory, repository, iterator, those are the most popular ones. There's some other ones sort of on the other end that are less common. Some of it depends on what kind of code you write. So the observer pattern is very common if you're writing thick client code. It's somewhat more common if you're doing like MVVM style patterns in the UI that you're writing. There's a few that I think are pretty much the most common based on this results as well as my own experience. And those are the ones I want to talk to you about this afternoon. And so we're going to look at this top 5-ish list of patterns. It's zero-based because I'm a developer, but also because the singleton pattern is really what I would call an anti-pattern. And so we'll talk about that first. And then we have null because that's not a number, so it doesn't count in our list. And of course, there's many other patterns, but we don't have time for them today. So the first one we're going to talk about is the singleton. The singleton can be summed up to say there can be only one, as with the Highlander. And the intent of it is just that. It's to ensure that a class in your system only has one instance. The thing about the singleton pattern that makes it somewhat of an anti-pattern in my experience is that that class is responsible for making sure that there's only one instance. And that's the part that makes this a problem. The typical structure that you'll see, this is C# for a singleton, looks a lot like this. This is like the naive implementation of singleton. If you're using this in a system like ASP.NET, you can have problems because this code is not thread safe. Multiple threads could enter into the part where it instantiates the singleton. That may or may not be a problem. It just depends on how important it is that you don't instantiate multiple versions of this thing. So that's the line of code that could get run by multiple threads in a heavy load environment. How you can use a singleton is very straightforward, just like any other instance. So you can call methods directly on it. You can assign it to variables. You can pass it around as a parameter, etc. If you want to write a singleton in C# that is both thread safe and fast, this is the code that you will write. And if you want to see why, there's a great article by John Skeet, who's a very famous Stack Overflow and C# guru. The URL is here. You can Google for it. But this is totally the way that every one of us would implement singleton if our boss said, hey, go make sure there's only one instance of this class, right? Anyone? No? All right. So this is really esoteric, I would say, code. But he has demonstrated, and again, read the article if you want to see why, that this is the fastest thread-safe way to do it in C#. What I would contend for you is that rather than going through this, do your singleton effect through something else. Don't do it in the class itself, and that avoids the entire problem. So let's talk about what some of the issues are with singleton. First of all, the whole thread-safe thing. We've talked about that. Secondly, and more importantly, it introduces tight coupling between parts of your system. So if you have a singleton in your system, let's say it's for talking to the database, or let's say it's for talking to your configuration system, which are both very common examples of singletons in real-world applications. The problem with that is that every single method that references that singleton is now tightly coupled to the database or the configuration file. And that makes it very difficult for you to make changes to that method or to test that method using unit testing as opposed to integration testing. Again, so makes it difficult to test. That's the main thing that makes these an anti-pattern. The other thing is that this violates the single responsibility principle. And the single responsibility principle basically says that your class should only do one thing. And if that class has to manage its lifetime and do something useful in your application, it's got at least 2 responsibilities, and therefore it's going to violate this principle. So it's a better idea, typically, to put that responsibility of managing object lifetimes somewhere else. The typical way that you would do that today in .NET is with an IOC container. IOC containers are very prevalent now. IOC stands for inversion of control. You might also hear them called DI containers or dependency injection containers. And what they are is basically just a factory on steroids that can take any kind of a request for an object, see that it needs certain other objects in order to do its job, and fill those needs. And when it does so, it can either create new instances of types, or it can use a singleton or various other object lifetime options. With regard to testing, it is not true that you can't unit test these methods that reference singletons, or for that matter, static methods. There are commercial tools out there that will make it possible for you to do that. The question is, why would you want to write your code in a way that makes it so only certain commercial tools can be used to test it instead of traditional testing methods? So I would say if you can write it in a way that doesn't require that, that's probably better. If you want to manage object lifetime in an IOC container, this is an example of what it looks like. This kind of stuff is actually baked into ASP.NET 5, which is basically beta 4 now, I think. Visual Studio 2015 RC was just dropped at build this week and has the bits for that. You can download it and play with it. So it has this dependency injection stuff and a container built into it. This is an example using an open source tool called Structure Map that I'm partial to. And it basically shows you 3 different ways that you could wire up object lifetime for types. So in the first case, this hybrid HTTP thing basically says, I need a new instance of this for each web request. And this is common for things like Entity Framework. You don't want to have Entity Framework set up on a web application as a singleton. You want to have 1 new instance per web request. You also don't want to have 1 new instance for every single object that asks for it, because that gets you into other problems. So that's the appropriate lifetime for Entity Framework. And you can do it with 1 fragment of 1 line of code in your IOC container configuration rather than having to write your DB context to figure it out or do any kind of code yourself for it. If you do need a singleton, for instance, you're using nhibernate, and Hibernate has a session factory type that does some expensive stuff. And you don't want to do that on every single request. That would be bad. So rather than making that happen every single time a request is made for it, or every single time a web request comes in, you want to do that once. And so this is an example where you really do want a singleton, but you don't want to implement it yourself. You just can do it right here. .singleton, done. Otherwise, if you just want to get a new instance every time, you can just say, for this type, use this other type. Does that make sense? Any questions? Anybody want to defend the singleton that I've maligned here today? All right. Well, I either did a good job or you're too scared to speak up. All right, so the next pattern I want to talk about is called the strategy pattern. And the strategy pattern is one that I am still in the overzealous stage of, I think, because I love this pattern. This pattern is like God's gift to testability. And so the strategy pattern is basically the pattern you're using if you've ever done dependency injection. And so where you take the thing and you extract the interface and you put it in a constructor and you set a private field and you pass the thing and set the parameter. I'll show it to you in a second without my hands. And that's how strategy works. If you read the definition of the strategy pattern in the Gang of 4 book, it will tell you that the intent of strategy is to encapsulate a family of related algorithms, which doesn't sound exactly like what you do when you do dependency injection, at least to me. But that's what they're talking about. And those algorithms are things like how your code does what it needs to do, as opposed to the interface that the client code needs to call your code. The other part of this intent is that it lets the algorithm vary and evolve independently from the classes that use it. And what this means, and usually it's the other way around in my experience when I'm writing code, the algorithm, which is, let's say, how I go get data out of the database, doesn't usually change that much once I get it written the first time. But the code that is using it needs to vary independent of that, because I want to be able to test it and tweak it and change it and write it, one way when it's in production and another way when I'm in test. And now I'm going to write some performance tests and I want to be able to configure it in a way without having to, change a lot of code and add a bunch of if statements or things like that. And I can do all those things if I follow the strategy pattern. I can just swap in different algorithms or different implementations of that interface. And it makes our code much more flexible. Now, that flexibility comes at a cost. Your code might be a little more difficult to follow or understand, depending on how many levels of abstraction you have in it. So we'll talk a little bit about how much is too much or how much is appropriate. But the general idea with the strategy pattern is that you're trying to decouple some of the logic inside of your class and push it someplace else and make it so that the calling code only knows about this interface that it needs to work with. It doesn't need to know about how the sausage gets made. So some of the things that this enables are the single responsibility principle. If you've got classes today that are doing some work but also talking to the database or also reading from a file or also sending an email, it's got too many responsibilities. It knows about too many things. And so those are all things that you can pull out, put them inside of smaller classes that just do one thing, and then use the strategy pattern to inject those dependencies. The open-close principle basically says that your classes should be open to extension, but closed to modification. And what that means is that you should be able to change what your class does without actually cracking it open in a code editor and changing the code. You should be able to change its behavior by passing things into it. It could be a parameter. That's the simplest way. And it could be a parameter on the constructor, which is all the strategy pattern is. It says, let's just parameterize this object and pass something in to affect how it does its job. All right. As far as the structure for this, how many of you like UML diagrams? Anybody? All right, so this is a UML diagram. They used to be popular in the 90s. People don't use them as much now, but basically this is what the strategy pattern looks like. And it says, hey, I've got this context that needs to do X. I'm going to define what X looks like from an interface standpoint. I'm going to create this interface. So I've got this strategy interface, and it has a method on it called execute. And then I can make implementations of that interface. I can make as many of them as I want. And so they're listed down here. And I can swap out which one of those I want to pass in as a parameter to my context, to my client object. And that's how this strategy pattern works. It's, again, basically dependency injection. Common use, dependency inversion, dependency injection, decoupling. Refactoring steps, if you've got code that has too many responsibilities or is too tightly coupled, the easiest way to refactor to use the strategy pattern is to create a brand new interface that only does what your class needs it to do. Then create an instance of that interface and just copy and paste the code straight out of your class into that implementation and then pass this thing into the constructor. Another thing that you want to avoid, sort of an anti-pattern, is this idea of hidden dependencies. Hidden dependencies are anything that your class needs that isn't explicitly requested in the constructor. So if you're looking at a class and it says, you can just new it up and it doesn't require anything, but then you actually go to use it and it blows up and says, oh, I don't have a database connection, or oh, I can't find this file at such and such path, then that class was lying to you when it told you that you could just new it up. You should sort of do this design by contract step with your constructors where you're explicit about the dependencies it has. If it needs a database, then it should have some interface that is how it gets the data. If it needs to talk to a config file, again, it should have some interface that says, here, I need these settings. I need a settings class or a config class. And you pass that in. The great thing about that is that then later on down the line, if you need to change how it talks to the database or where it gets those settings, you can do that without touching that code, without breaking the open-closed principle. So follow the explicit dependencies principle. Avoid hidden dependencies. Avoid making non-stateless static calls. So static methods I already mentioned briefly with singletons, but these are another thing that causes coupling. And where you find static methods that make your code more difficult to test, it's a good idea to extract that out into an interface and pass in an instance of that interface in order to get that functionality. Now this doesn't mean that all static methods, which by the way includes of course all extension methods, it doesn't mean they're all bad or all evil. What we're talking about here are ones that have side effects. Ones that write to the file system, send emails, talk to databases, do things outside of your code. If the only thing the extension method does is format some string or do something like add 2 + 2 and it doesn't have to go anywhere else, then those don't have any side effects. They're not going to be any more difficult to test. They're not coupling your system to some other system. They're fine. It's only the ones that are going to add coupling that you should worry about and think, hey, I should think whether or not I want to have that coupling in this class. Related to that is instantiation. In your methods, if you're instantiating up classes, you're making a decision. When we talk about the single responsibility principle, that decision that you're making there is which other collaborating objects is this method going to work with. And that could be a decision that gets made somewhere else. We'll look at some other patterns you can use to change up that decision, like the factory pattern. But that's something that you can inject and push that decision onto somebody else. So that you can just say, hey, I need something that lets me send an email, or I need something that lets me get the current time. I don't need to call datetime.now right here and couple my code to the system clock. So a way that you can remember that is when you're looking at your code and you see new, just remember that new is glue. Anywhere you see new in your code, you're gluing this method to whatever it is you're instantiating. And decide whether or not this is the appropriate place where that decision needs to be made. Because you can think of that as an other responsibility. Your class is doing whatever it's doing, and now it's also deciding who it's doing it with. And that who it's doing it with decision could be made somewhere else. It could be made in your IOC container, where you wire up all of the objects that you're going to use in your system, and that might be a better place for it than inside this method. All right, let me get a drink. Any questions? No? All right.
Actually, I got one for you.
Okay.
So you said instantiate, you go back 2 slides, you have a point at the top there. No, that's it right there. Classes should be declared, dependencies together structure. I suppose I'd love to see an example.
We will see an example in just a moment. So the question was, classes should declare dependencies in their constructor. What does that mean exactly? What that means is that you should figure out what those things are that you need. Ideally, they're abstractions, so they're interfaces or they're base classes. They're not specific concrete types. But even if it's a specific concrete type, that's still not the worst thing in the world to pass that in. But basically, create a parameter on your constructor for that type and pass it in and then set it to a local instance variable. And again, we'll see an example in a second. And then within your code, use that local instance variable everywhere so that your code, your class, doesn't new anything up. I write a lot of ASP.NET code. And one thing that you typically want to avoid is like in your MVC controllers, your MVC controller usually doesn't need to have the word new in it. It might, well, it's not true. When it returns something, it might return a new view or a view result or some other UI thing. But it shouldn't have anything that's newing up a business service or an entity framework DB context or things like that. Stateless things like DTOs, data objects, strings, your views, it could new those up. But your model stuff should be coming into it from somewhere. All right, so new is glue, creates tight coupling. That's not to say you shouldn't use it, right? Let's be clear. I'm not saying new is bad. Go tweet. Everybody tweet. Steve Smith said new is bad and we shouldn't use it in our code. Good luck getting your code to run if it doesn't have new in it somewhere. The thing that you're noting here is making it conscious to you whether or not this is the place to make that decision of which thing to new up. Or if that's a decision that you can delegate or defer to someone else and you can just have them pass in the thing that someone else decided was the right thing to pass into you. Okay? And if it's simple stuff, if it's you're doing up a string or you're doing up a date time, if it's not coupling, then don't worry about it, right? That's fine. If it's not going to make it harder to test or harder to isolate from other parts of your system, you can use new all you want. But if you're newing something up, and this is the really evil one, is when you new something up and in its constructor, it does a bunch of coupling stuff, like talks to the database and makes a web service call and sends an email and sets your computer on fire. That's an object that you don't want to be newing up anywhere you can help it. You want that to be a very conscious decision somewhere way up the call stack that you're going to use that killer, deadly, awful object rather than in your method. And you don't want to use that like spread out throughout your whole code. Yes, question?
So you're not including new and app like view models?
Yeah, I mean a view model is just a value object, basically. It shouldn't have any dependencies. View model should never talk to a database or send an email or do any of this infrastructure stuff. So a view model would be totally fine to instantiate. All right. Another interesting thing for those of you that are still working with WebForms, WebForms is not dead, but it's not really moving forward quite as fast as some other parts of ASP.NET. And again, I'm assuming an ASP.NET background that I know most of you may not have. But if you happen to be using WebForms and you're thinking, well, I can't use this because I don't have all that MVC goodness that lets me wire things up to the constructor, you can actually still do dependency injection through the properties of a web form using this technique. So this works with structure map. Some of the other IOC containers support the same idea. The way this basically works is you would have a base page in your application that all your pages would inherit from. And in that base page, it would call this one line of code that says build up there. And what that does, it tells structure map to go look at this class and see if it has any properties that it knows how to set. And so then you would set a property on it of some type, like say album repository here, type I album repository. And then it would automatically know, because of this configuration in the top right, to go through and find any such properties and set them. And then since that happens at construction in your web form for the rest of its life, and page load and page pre-init and page pre-post render, whatever, all those events that eventually led to ASP.NET Web Forms going out of favor, you can use that dependency. And you don't have to new up a DB context or a repository or whatever in the web form. All right, so how many of you still use web forms or are using web forms? Cool, not that many. All right. I did web forms for a long time, but I like MVC better. Web forms is great for some things like reports and things like that, though. All right. The next design pattern I want to talk about is the repository pattern. And the repository pattern, how many of you are familiar with this right now? It's very popular these days. All right. It comes from domain-driven design. And it basically says, hey, let's take data access and put it behind an abstraction that looks like a collection. So whenever I need some data, instead of making an ADO.NET call or opening up a SQL connection or getting back a data set that then I have to do stuff with, I'm just going to say that I've got these objects, and domain-driven design is all about modeling your problem as objects that have behavior. So I'm going to say I've got these entities that I'm going to work with, these objects, and they come from somewhere. I don't care how I get them, but I get this list of them or just one of them, and I can iterate through them, or I can use link statements to find a subset of them that I want. And the fact that it might be getting those from a database or it might be getting them from a web service call, I don't care. All right, put that behind the abstraction and my code can just treat it like a collection. And so it does a good job of simplifying the client code that has to work with this data. It no longer has to know about opening up connections and cleaning up connections and readers and data sets and all that stuff. It just works with it as if it were a collection. I've done programming for a number of years now, and I've seen this sort of evolution of data access over that time that kind of leads toward the repository. And the initial data access that I worked with when I started my career was with ASP and Visual Basic 6, and there wasn't any concept of separation of concerns in the organizations that I was working with and the code I was working with. And so we had all the logic kind of commingled with the UI. So we'd have HTML with loops to create it and talking to record sets or data sets. And so everything was kind of a spaghetti code mess over time. Sometimes you would move the data access logic into the code behind in ASP.NET, but it was still part of the UI layer. And so when you look at your architecture of your system, it would look like this. You'd have this user interface layer, and it would talk to the database. And at compile time, it would look like the green arrow, and at runtime, it would look like the red arrow. Or sorry, I guess that's blue, the blue arrow. The problem with this is there's no abstraction. So it also tended to lead to a lot of duplicate code inside your UI code. So the first thing that people would do is they would create helper classes, and this would cut down on the duplication dramatically. So instead of calling all the ADO code inside the UI, you would put it behind a helper method. You could use something like this data access application block and shrink down the code, but now your logic just looks like this. You've got user interface, call that helper method, still talks to the database. Not a huge improvement. Well, I mean, it was a good improvement, but it didn't get away from this coupling to the database. And then we'd say, okay, let me back up one. We would come in and say, well, we could also put in a business logic layer or a data access layer instead of these helper objects. But at the end of the day, the arrows still followed the same path. Whatever you compiled was exactly what it looked like at runtime. And since you wanted, when you compiled it, to be able to talk to an actual database, that's what it would do every time. It was very difficult to get those arrows to follow another path. And the repository helps with that, along with dependency injection with the strategy pattern. And so this abstraction that you can add is called the repository pattern. All right, so tight coupling, it's bad. Here, if you use the repository pattern, you can make it so that what happens when you compile your code does not follow the same path as what happens when you run it. And this, as it turns out, provides you with a great deal of flexibility in your code. You now have a composable system of objects instead of this tightly coupled, completely unchangeable set of objects. Where now you can say, okay, at compile time, it's going to use the interface. At runtime, I'll plug in this thing that talks to the database. At test time, I can plug in something else. I can plug in an in-memory database or a test database or a mock database and make it so I can run tests on this thing without having to have a database involved, which makes testing much more difficult. All right, so to implement one of these, it's basically a data access pattern. It helps with single responsibility principle because you can take all the data access concerns and push them into another class. And it certainly helps with testability. And these are some of the reasons why it's fairly popular. There are a few different ways you can construct these. I could do a whole talk just on designing your repositories. And so some common ones are to create a repository per class or per type. You can also make a generic repository that's an I repository of T that works for any type. If you're following domain-driven design, you can do repositories per aggregate root, which is a good design that keeps your code from being as coupled at the data access level. If you don't know what that means, there's a course that I wrote with Julie Lerman on Pluralsight that you can watch on DDD. Another way that you can do it, and this is sort of following the command query separation, is that you could have some repositories that do reads and some repositories that do writes. And where this can help is if you're in a performance scenario where maybe you want to have some caching involved on the read side or some queuing involved, typically on the write side, you can break those things up separately. And if you have some classes that need both reads and writes, there's nothing to prevent you from creating a repository interface that rolls those two things up together into a single interface. All right, so someone was looking for an example. Here's an example that's going to use the strategy pattern with the repository. And so with ASP.NET MVC like 3, they ship this music store sample. It's pretty simple. And it looks like this. It's got a DB context that is just newed up right inside the code and makes it impossible to test this code without having a database in place. Because it's right there. I mean, it's not in the constructor, but when it gets compiled into IL code, it's in the constructor. And it'll instantiate that. And when it does, the first thing it's going to do is try and open a database connection. And if your database isn't there, it's going to blow up before you get to line 1 of your code. So the first thing you need to do is extract an interface. And you don't have to extract out the best perfect interface. You don't have to spend an hour researching on Stack Overflow repository interfaces to find the perfect one. When you're doing strategy pattern and you're trying to just decouple your code, you just need an interface that works for your one class. So make that interface. Don't try and make the perfect interface for your entire company. And so in this case, we need one method. We need this get top selling albums method. We put that in the interface. Then we're going to go copy and paste our code right out of our controller and put it into an implementation of that interface that has this one method. And in that same implementation, we'll move the instantiation of the DB context, the music store entities type up there. And then inside home controller, this is the part where we're going to be explicit about our dependencies. We're going to say this controller does not work if it does not have a way to get this list of albums. And so it's going to say, I need an iAlbum repository in its constructor, and there is no other constructor here. There's no way to make one of these without that dependency. So it's not just explicit, it's also enforcing in your code the idea that this thing only works if you give it what it needs. And yeah, you could pass one in that has like a not implemented exception and use it at your own risk, but your code at least is broadcasting through its interface, through its constructor, these are the things I need to do my job. And this code will run exactly the same way as the original code did, but now it's not coupled to the implementation. Any questions about this? Question? Where do you normally store your interfaces within like the project structure? The project structure that I like to use goes by a few different names. It's commonly called the ports and adapters or onion architecture. You can Google for either one of those and you'll see it. I talk about it at length in my Pluralsight course too, so you could watch that. And the way it looks is basically I always have 3 projects. I have a core project, and the core project is where things that don't have dependencies live. And so if I have logic in my code that does not depend on anything, I put it in core. And that will include most of my interfaces. It'll also include my entities and my value objects, some of my events, maybe some services. All the core business logic of the domain that I'm trying to model goes in there, and it's extremely testable because it has no dependencies at all. There's no references to anything off of that. And then I've got an infrastructure project. And in infrastructure, you could have more than one. You could have several. But infrastructure has things in it like data access. So all of your repositories will live in some sort of infrastructure project. And the way that's laid out, the infrastructure project implements the interfaces that are in core. So this is the dependency inversion principle, where instead of having your business logic layer depend on your data access layer because it calls it, you're going to have your data access code depend on your business logic and invert that. So the infrastructure layer depends on core. The user interface, your web project, your MVC, whatever it is, WinForms, WPF, it is going to reference core, and it might reference the infrastructure project as well, or you can also just copy the infrastructure DLL into that bin folder of your client code, and it'll work that way as well. Does that answer your question? I don't have a slide handy to show you that architecture, but that's where they live. Is they should live in the core, implementations should live in infrastructure, UI should reference core and will use infrastructure at runtime, but shouldn't have any direct dependencies to it. All right. And the next question here is, where do repositories live? Which is related to that question of interfaces. And this is going to say, hey, put the interfaces in core, put the implementation in infrastructure, and then the UI is going to reference those. So it's a very good segue. That was my next slide. Any other questions? Yes, sir? What interfaces would you not put in core? Sometimes you have things in your infrastructure that need to have interfaces that use infrastructure-specific types. You may be using a third-party API, and that third-party API defines some interface that has types that are things that are common to that API. There's this object type of, RSS object or something, let's say, and it's defined in this infrastructure client you're using for RSS reading or whatever. And so you want to create an interface, but you can't put that interface in your core because then you'd have to create a dependency on this third-party library that you're using. So those types of interfaces would have to go in infrastructure just because they have a dependency. If it doesn't have a dependency, then it should probably go in core. All right? All right, the next one we're going to talk about is the proxy pattern. How are we doing on time? We're good. 407. All right, cool. The proxy pattern is a design pattern that basically lets you have an object that is going to control access to another object. And there's a few different uses for this. The common ones are things like remote proxies for web services. So if you ever have called a web service, generated some code that creates the interface you're going to talk to on your end and hides away from you all the details of talking over the wire to get the data, that's the proxy design pattern at work. It's also useful for lazy loading implementations. So if you've used lazy loading in an ORM, for instance, like in Hibernate or Entity Framework, that's using the proxy design pattern under the covers. What's going to happen is when you think you're actually accessing a property of one of these objects that was hydrated for you by one of these ORMs, you're not necessarily really accessing that property. You're accessing a proxy that knows how to get the data for that property. And when something calls it, it will go and execute the call to go fetch the data and bring it back. It can also be used for security and access control. The structure for the proxy design pattern looks like this. There's that UML again. And if you look closely at this UML, you'll see that it looks awfully close to the strategy design pattern's UML. They can be implemented exactly the same as one another. The difference between them is their intent. The strategy's intent is to let these things vary independently and swap them in one for the other. The proxy's intent is that access control. Incidentally, it's also very close to the decorator pattern, which again is just a matter of intent. So a really useful way to use the proxy that I have found is to add caching to repositories. So if you're using the repository pattern and you're doing a web application, which is kind of my background, very commonly it's going to help you if you add some level of caching. And caching is like the easiest way to dramatically improve the performance of your web application for anything that is heavily using the database. And so if you go into your repositories and inside each one of those methods you put in caching logic, you're violating several principles. You're going to have this duplicate code, so you're violating the don't repeat yourself principle. You're going to have multiple responsibilities because now your repository has to know about how to get data and how to cache it and what the rules are for that. And so that's not what you want to do. But what you could do is create a different layer that has the knowledge of the cache and wrap that around your repository. And that would be using the proxy pattern, because it's going to control access to the data layer. It's going to say, do I have this in the cache? Yes, okay, then you can just have it. No, okay, well now I'll let you go to the data layer to get that data that you're looking for. So separation of concerns can be achieved this way with caching. And here's an example of what this might look like. So we already saw earlier on that album repository just has one method, knows how to get the top albums, but that's on the home page. I really don't want every time somebody visits the homepage for my music store to make a database call to get the top 5 most selling albums. It's probably not going to change second to second. So that's an ideal candidate for me to cache. And maybe I can't use output caching on the page, which would cache the entire HTML output, because the user might sign in and then they've got their name on there, or there might be some custom suggestions for the user that I don't want to show to every user. I want it to be customized for that user. So I want to do it at the data level. And so this is how I could achieve that. I could write this code that says, okay, I know how to do the caching logic. And this is an example of how to do ASP.NET caching. But I need to still go and get the data using the album repository. And this is the one example of how you could do it. You could also do it with inheritance, which would be another variation on this theme. Now the trick with this, if you were paying attention or if you already know how IOC containers work, is the interface here. When this is written the way this is, I now have 2 different implementations of iAlbum repository, and I want to use both of them. I want to use the iCached repository when an MVC controller comes looking for this. But in this constructor right here, I want it to be the real entity framework or whatever, go get me the real data type. If I don't do some extra work, I'm going to end up with a Stack Overflow exception here because the IOC container is going to say, oh, I need to create an iCache thing, and it needs an iAlbum repository. Well, my dictionary here says that whenever I need one of those, I'm going to use the cached one. So I'll create a cached thing. What do I need? Oh, I need an iAlbum repository. Repeat endlessly. So you can achieve this in structure map with one line where you just say, okay, for this rule, I want you to use the cached one, but for its constructor, I want you to use the EF one, the entity framework one. And just with this now, you've got this caching layer that you can tweak independently. And if you want to turn caching on and off globally in your system, maybe you're doing some performance testing, or maybe you want to try a different type of cache. Maybe you're using Redis now instead of the in-memory cache. All you have to do is change it right here in your IOC controller. You don't have to change it in 100 different data access methods or in every single controller in your UI layer. So it makes it so there's one place to go and make those changes. There's a host of other ways you can use the proxy pattern, but I don't have time to talk about them today. So the next pattern I want to talk real quick about is the command pattern. The command pattern basically says that you're going to take a verb or an action that normally we would model as a method, and we're going to model that as an object. And that's a little bit different than how we usually model things in object-oriented programming, but that's the heart of the command design pattern. And so it looks like this symbol down here, and the idea is you're going to represent this action as an object, and it lets you decouple when you're going to perform that action from the thing that's requesting that it be done. Some common uses for this are for delayed execution, for creating the ability to log what happened. You can even do undo, redo with this type of a pattern because you've got this list of all the actions that were taken, so it's not difficult to reverse them and play them backwards. In terms of uses, one of the common ones is for scalability. So how many of you have ever ordered anything from Amazon.com? Anyone? Oh, yeah, you too? Oh, I love that site. All right. When you ordered something from Amazon.com last time, what did the page say after you clicked checkout? Say what? What's that? Your order has been processed, pending. Does it show you a list of what you bought? Yes? No? Okay, if you go to 99% of the websites out there on the internet with Bob's e-commerce suite that they used, and you buy something, almost every one of them comes back and says, hey, here's all the stuff you bought. Here's how much it costs. You could print this page. You go to Amazon, which is like the biggest store in the universe, it doesn't do that. It says, thanks for your order. Here's your number, right? And that's it. And if you didn't trust Amazon, you'd be like, really? What did I order? Are you sure it went through? Did I get that? But Amazon doesn't actually do anything when you check out except put something on a queue. And then a few minutes later, or a few seconds later, you're going to get an email that says, thank you for your order. They don't do anything like check your credit card, process your credit card, check to see if we have inventory, check to see when I can ship this thing, see if it's on back order, blah, blah, blah. Most e-commerce suites that people write do all that stuff when someone clicks checkout. Sending an email. Most people do that in the checkout method, most developers. Amazon doesn't do that. Amazon just fires off a thing on a queue and sends you back this page in like 2 nanoseconds, which lets them scale really, really well. We could use the same technique in our code to allow us to take an action and decouple it from the user interface action. So when the user says, I want to do X, think about whether or not you have to actually do that thing right then before you return back the UI thread to the user or send back a new page or whatever. Or could you just package that up as a command, serialize it, put it on a queue somewhere, and let some other service pick it up and do it sometime in the near future? And then give the user some notification to say, hey, OK, that thing you asked me to do, it's done now. All right, so that's where the command pattern comes into play, and it can be very valuable. Yeah?
So would delegates like a func or an action, would that fall under this category?
So the question is, would a delegate or a func or an action fall under this category? It can. Certainly, as long as it lets you defer or delay the execution and have it take place out of band and return immediately from your function. The typical way with the pattern is to instantiate something, pass in whatever state it needs in its constructor, and then the command object itself probably just has one method that says execute. You could literally create one interface in your whole application for iCommand that has one method, void execute, and that's the pattern. And now you can serialize these things and pass them around, and when the processor needs to run it, it just dehydrates it off the queue or out of the database or wherever you stored it and runs the execute. All right, then the factory pattern, moving right along. The intent of the factory pattern is to separate the responsibility of creating an object from the type that needs the object. And we already talked about these IOC containers I mentioned. IOC containers are basically just factories on steroids. Honestly, in most of your applications where you need a factory, you could probably just use your IOC container for it and just create a rule in your IOC container that would be the factory. I don't recommend that you necessarily do that, but most IOC containers could, in fact, do that. Another nice feature of this is that you can defer the creation of expensive objects until when they're needed. Sometimes you're going to have code that only needs to have this instantiation of this type in a certain if check, in a certain conditional. And maybe that conditional only happens 1% of the time that this method is called. You don't want to have to instantiate that expensive object every single time as a parameter to pass into that thing or at the top of that method scope when it's expensive, but you only need it 1% of the time. So the factory can be a good way to avoid that and defer that execution, or that creation rather. The other thing you can do is decouple the decisions about which objects to make from the methods that are calling those objects or needing to use those objects. That can be your IOC container, but it could also be something where you store everything in a configuration file, or you store it in a database, or you have some folder that you drop plugins into. These are all examples of ways you can decouple what's going to run from the class that needs to use it. A type that was introduced into .NET a couple years ago is called lazy of T. And lazy of T is a handy utility for this sort of thing. You can use it to do this sort of decoupling and this lazy instantiation. So instead of saying that your class requires a DB context, you can say it needs a lazy of DB context. And what will happen is the first time something actually needs to use it, it'll instantiate it at that moment. And then further requests for it will use the instantiated version. So it's a very useful way to do that. The other thing that lazy of T can do is avoid null reference exceptions in your code. If you look at this example code right here, up here I've got this property. It's using this instantiation where it's going to say, well, if I don't have one yet, I'm going to create one and pass it back. In your code, you may or may not have a standard for your developers that says, we will always access our types through the properties, not through the backing fields, right? Do any of you have a standard like that? Most people don't, right? We usually just say, yeah, we can just go hit the fields all we want. So in this case, if you do that, if you come down here to this line that says, customer.company name, if nothing has requested customer yet, it's going to be null, and you'll get a null reference exception. And it's not really trivial to make that safe in your code. Unless you come and do that with lazy of T, With lazy if t, now it's safe to use those backing fields. You can use the capital customer, you can use the lowercase customer, it doesn't matter. Either way, it's going to work because the underscore customer initializer isn't really the customer, it's the lazy operator. And so to use it, you have to call the dot value, which will instantiate it at that moment, and then you can get to its stuff. And so this lets you have both the lazy instantiation and have safe access to the backing field within your code. Alternative ways to create factories are you can write your own method. There's a bunch of different ways to implement factories. They all boil down to having a method. It's just a question of where does that method live? Does it live on the object that you're creating? Does it live in its own class, which is probably better for single responsibility? You can use your IOC container, as I mentioned. Or for simple things, you can certainly just use lambda expressions or func of t and pass those things in rather than the full type. All right, here's my diagram I found when I searched Google for null objects. Beautiful picture. I already used that joke at the start when the technical difficulties happened. Null object is the last pattern I have time for today, and the null object pattern is a great way to cut down on stupid if checks in your code that say if something is or is not null, do this, otherwise do that. And the problem with that logic is that sometimes you forget it. It's a pain in the butt. It makes it so that your code is more obtuse and difficult to see what it actually does because there's all these if checks everywhere to see if something's null. If your code has an object hierarchy that is, this thing, dot that thing, dot the other thing, dot foo, and there's the thing I need, you're going to end up having to do null check after null check after null check to the extent that the language is actually putting in better and better operators to make this kind of kludgy code easier to write. C#6 has more operators to make this sort of null checking easier to do in one line. If you use the null object pattern, you can avoid having to check whether or not things are null. And all the null object pattern says is that instead of returning null from things, return back an instance. And return back an instance that means null. Like if you've got some code that was going to do something, but if it was null, it was going to do something else, well, create a null instance and bake that something else behavior into it, which I'll show you an example of in just a second. So you can use this whenever you have a method that works with something else, and when it's null, you need to change your behavior. Implementation is real simple. You just have a base type. You normally implement it one way, but you create an instance of it that is the null implementation. And the null implementation should simply do nothing for all of the methods and properties and things. What nothing means might be different in each scenario. So as a concrete example, a very simple one, let's say that I want to look up a customer, and then I want to print out the customer as a string, and I've got this method on customer called .toFormatted string, and it's going to pretty print the customer for me with this. Now, unfortunately, that call to .toFormatted string is going to blow up with a null reference exception if I didn't actually find a customer that has that phone number. And so I'm going to fix that by using an if check. And unfortunately, I'm going to do this all over the place in my code, anywhere I want to use customer and print stuff. If I change this code, and back up for a sec, I'm getting this code from this repository up on the first line. So that's where I need to implement this null stuff. If I change this code to use a null object, it looks like this now. It's that much easier. I don't have to do any of the null checks. The first thing I'm going to do is I'm going to implement this not found customer, call it whatever makes sense for your domain, and I'll show you that in just a second. It's common to make that a static property on the type. Right? So now I can go anywhere in my code and I can write customer.notfound, and it's very discoverable. And then that null customer simply is going to print out whatever I wanted to print out in the case where I didn't find a customer. So in my original code, in my if it's null check, I said, well, if it's not null, I'm going to say whatever I said, customer not found, right? So I'll put that inside the not found customer's format string, and now I can spit that out inside the object and get rid of the if check. And now I just move the if check into the repository. And there's different ways to do this. I could even get away with the null check. I could say, if such and such dot any, do this, else do that. I don't do that here because that would require 2 database calls. But this is basically where you can have one place to do that check instead of scattered throughout your code. How many of you have if such and such is not null scattered throughout your code today? Yeah, it's a common problem. It's actually thought to be one of the most expensive mistakes ever made in computer science is the introduction of null into systems. So getting away from it and using the null object pattern can really help cut down on how much of that code you have to write that's this boring plumbing code that you just have to write to make your code work correctly. All right, so I've showed you a few different patterns today. I want to leave you with this. Practice PDD, which is pain-driven development. And what that means is don't go and be the overzealous person that's like, all right, Steve said these are the patterns. I'm going to use them all. On this class, right now, I'm using them all. Look at these things as tools that you could apply if you see something that's causing pain and has the symptoms that I talked about. And then only use it in that case. So I've got about 5 minutes. I want to tell you one quick story from the real world before you all take off to go see the movie. And this is basically a real story about performance problem. I had an ad server that was showing banner ads a few years ago on development websites. And we made some refactorings with how we were doing the caching and the cache dependencies. And so what happened is the web servers started to look like this. And so you would see the memory just go up and up and up and then drop like a stone. And whenever that happened, CPU would go at 100%. And the server would stop serving ads, which is bad. And that would take like a minute. And then it would come back and it would do this thing again. And I spent like a week trying to figure this out. I finally called Microsoft, opened up a ticket, gave them a dump of the memory. And they were like, you know, you're instantiating a lot of cache dependency objects. Because I was using the SQL cache dependency, which is an awesome thing in ASP.NET that will automatically update the cache whenever the contents of a table changes, which makes it so you don't have to make a decision about how long should I cache this. You cache it forever, and if the data changes, boom, the cache stops and you get the new data. So you can have your cake and eat it too. The problem was when we did a refactoring, we pulled that dependency on the cache dependency out of a method and made it a parameter. And so we were passing it in, and that meant some other class was doing it up. And it turns out that this is bad. And the offending code looks like this, where that red arrow is pointing to this parameter that we introduced to say, okay, let's pass this thing in. And we made a helper method to do it, and we made it generic, so it automatically knew like which table it was working with. It was beautiful, it was great, and it ended up causing major problems in production. And we didn't notice it right away, so we didn't know that this was the thing that caused it, because it was weeks later that we saw the issue. So to fix this, all we had to do is switch it out to use a func of t, right there. So instead of saying, hey, this expensive object, I need it every single time. For one thing, I didn't know it was expensive. That was the thing that got me. Every time you instantiate a SQL cache dependency, I'd forgotten this a little bit, it makes a call to the database and says, hey, is that table enabled for cache dependencies? And comes back with a yes, no. And so in this code, these ad servers serve up a lot of requests. They're like 200 requests per second per server in a web farm, serving up banner ads and text ads and stuff like that. It's like a very, very small version of Google AdSense. But 200 requests per second across multiple servers, we're hitting the database. And when this thing got turned on, instead of those requests happening only when the database actually changed and the cache needed updated, we were going and asking the database for multiple different tables 600 times a second. Is that table ready for caching? Is that table ready for caching? And that was the problem. And so there's also this memory leak that we saw in that performance chart, all because we were instantiating this thing more often than we needed to. So you can pass in a func of t instead. And then when you need the thing in this one if statement here that only happens once in a blue moon, that's where you execute that method. You get that deferred execution, and you get much nicer corrected behavior. So it went from this to this, which was better. This was how it had been before we made our code better. And so we got it back to that and still were able to get the benefits that we wanted from our refactoring. All right, so I have no more stuff to give away. I have 2 minutes left before we're supposed to be done. I have a slide here with some references. These slides will be on StirTrek's GitHub repo. If you go to github.com/StirTrek, you'll find them there within a week. Summarize, design patterns good. Use them everywhere, but only when you know that they're going to solve a real problem. And I'm free for any questions you might have in the next 2 minutes. Anyone? If you're not sure where to go after this, the movie is not in this theater. It's in other theaters. And if you look at your badge at the very bottom of the schedule, it says which theaters it's in. And I will tell you right now, it's in 11, 18, 9, 17, and 8. Thank you.